Hi everyone, we're back at it here at the single node virtual machine Kubernetes system that I'm trying to stand up. Right now I'm at installing the worker components. In our prior video, I worked on standing up the container runtime. We stood up run C, container D service, and also installed the cryctl command line. There was an issue I found, not necessarily an issue, but more so kind of like an outdated config file that I noticed after the fact around the container D config toml file. And so I've since updated it locally in my virtual machine. I was using the version 2 spec and I switched over to the latest version 3 and updated this and restarted the container D service. It should be up. Container D. As you can see, it's active. I am SSH'd into the virtual machine that we had earlier. I'll show it again. So it's the same node. And today, or at least in this video, what we're going to cover are the container network interface plugins, kubelet, kube-proxy, and RBAC. So with that, let's get started. You don't need to cover this. So the prerequisites, attestation to the VM, which we are. All the services are up and running. You know what I want to do? I want to create kind of like a status script where I just do some CTL status. And I just want to grab these. So we check etcd, the API server, the controller manager, the scheduler, and container D service. Now it should just, well, let's change that for a moment. I don't want this to prompt me. Let's try that one more time. There we go. So it checks all the services. They're all up and running, or at least they're running and active. That's good. Want something basic. Hang on, I'm expecting a delivery at my house. And got a message from UPS. Hey, we delivered your package. We attempted to deliver and they didn't deliver anything when I checked my cameras. Anyways, let's get back on track. I need to update the shell variables. So let's look at that. All right, what do we need? We already have that. We already have that. Now we need this. Do we have vname? Do we have vname? We do, so we don't need to do that again. Okay. We don't need this. I wonder if this will work. Yes, it does. Perfect. Sorting does work. Great. Okay. And then we will source the env file. Of course, I need to do that. Okay. And I want to make sure that there's no duplicate CNI plugins, CNI spec, container D, Kai version. Okay, yeah, everything was good. So the pod cider, where is that? Is a full pod IP range in a multi-node cluster. Each node will get a slice of the range. Since everything runs on one node, it gets the entire /16 address space. Okay. Installing the CNI, the Container Network Interface plugins are executable that kubelet calls to get up networking for each pod. We use two standard plugins, Bridge, creates a virtual bridge and assigns pod IPs, and loopback configures the loopback interface inside the pod. So we're going to download what plugin exactly? Oh, it's the full set. Okay. So, all right, let's go into the downloads folder, and then we're going to create a install CNI. User env shell, and then we're going to have to source env file. So this will just, that's the package, the archive name. We download it. We create this OPT CNI bin folder, and then we unpack the archive there. Then we create the CNI network config on a directory. We define one. We define one for the bridge network and the loopback. Let's copy those two. With the pod cider block and the CNI spec version. And then the bridge plugin creates a Linux bridge named CNI0 on the node. Each pod gets a virtual Ethernet pair, one end inside the pod's network space and the other end connected to the bridge. The host local. IPAM allocates pod IPs from the pod cider range, and the IP mask flag enables source NAT, so network address translation, so pods can reach the internet. Okay. Okay. And I think that's all for the CNI. We'll create a separate script for a kubelet. So let's get this one started. And then we'll confirm the networking that it's supposed to create. Script's not right. Try one more time. No, that didn't work as expected. And that's because I interrupted the TGC. Yeah. Let's do that one more time. All right, perfect. So it downloaded the archive, unpacked it, and then created the directory. Okay, so download, create the directory, and then unpack into that directory. And there's our CNI plugins. That's good. Then we create these configurations. Of course, we won't be able to see it. Okay. And then it creates this one as well in the loop back. Okay. I need to check to see if these values are correct, especially these CNI ones. All right. Said that I don't see any, like the CNI 0 on the node, each pod gets. So we just installed the plugins and we've configured them, but I don't think anything's using it. That might be the kubelet. Is it the kubelet, or maybe one of these other? It's probably the proxy. All right, let's keep moving forward. So we've completed the CNI installation and initial configuration. Still don't see the CNI 0 interface, but we'll just assume that gets created later down. If it doesn't, then we'll take it one step at a time. So let's go and install kubelet now. So let's create another script, install kubelet.sh user in shell. We're going to source the EMBs file. We're probably going to have to modify it as well. Let's see. No, we don't have to modify it because it's already been modified prior. Okay, so we download the kubelet file at that, and then we make it executable, and then we copy it over to user local bin, copy the security files into place. Okay, so these are the certificates that we created at the one of the first videos that I made. And it's copying specifically the VM name ones. So like the node 01 key, the PAM file. So it's putting that into the kubelet directory. It's also making sure to create these two directories. So varlib kubelet, varlib kubernetes, copy the node key and PAM certificates to keep the varlib kubelet, copies the kubeconfig to kubelet directory, and then the certificate authority cert as well gets copied over. Okay. Then what's next? And then this is this the manifest? No, this is the config for kubelet itself. Okay, let's copy that and see what this does. So this is the kubelet configuration. This is the kind. Sorry, not the kind. That's the API version. The kind is above. Anonymous enable false, webhook true, and then we have the client CA file. Here's the TLS cert file, the private key file. One moment. That's the path to the container D. That's for DNS resolution. Does that even exist though? Let's check. It does. Okay, so that's the name server and then search. Okay. Okay, I think we're good. Excuse me. Okay. We're good with that. And then let's see, KE configuration details, cluster DNS is set to 10.96.0.10, which is the IP that the core DNS service will get in the next chapter. Okay. This must be inside the service CIDR block. Kubelet injects this as a DNS server into every pod. The authentication webhook enable true means kubelet verifies API requests by consulting the API server. And we did disable anonymous authentication. There is no register with taint section, unlike the original guide where control nodes are tainted to prevent scheduling. Yeah, well, it's a single node, so we can't afford that right now. Then we're going to create the service for the kubelets. Yeah, we need to create the systemd service file for kubelet. And then the commands to start configure, enable, and start. One thing I want to confirm is whether we need to pass in the certs here. Like how we did with the control plane control manager and the scheduler. Okay, so because it's already configured in the kubelet manifest, the over here, the kubeconfig YAML manifest right here, it already has it right here. That's how we don't need to do that. So it just needs the path to the kubeconfig, which we copy here, and the config file to this manifest. Okay, perfect. And then we'll run this verification manually once ourselves after all of this. So let's so install kubelet. Before we do that, so we're sourcing. Okay, just wanted to confirm the source command was good. With these scripts, I know that I could add error handling and all that jazz and make this more reproducible, but that's not necessarily the point of this series. It's more sort of to basic fundamentals, I guess, and learning how to stand up Kubernetes. Uh, Of course, in a production environment, you probably wouldn't want to be rolling your own, I guess, implementations. You probably want to use open source tools that are maintained by a community. Um, but for my case, again, this is all for learning. You got to start somewhere, the base fundamentals. All right, so kubelet has been installed, but the thing that I don't see here is status. And that's because I never added one. I never added the status command. So it'd be systemctl status kubelet.service. Great. So it is running. And then let's modify our status scripts over here. Just make these consistent. And then we will run our script. Okay, perfect. Everything's progressing nicely. So we have kubelet now. Container D. So we created the CNI. We didn't create it, but we installed CNI earlier, and we didn't see the networking. I'm still not seeing the network, so it doesn't look like kubelet is the one that maybe there's some additional steps that need to be done, but let's see what happens when we do a get nodes. Whoa, that's nice. We actually have the single node itself that we can schedule to now. That's great. And is it in ready status? Yeah, it is in ready status. Is running, yep. And the CNI plugins are properly configured. If the status shows not ready, says that the CNI plugins are properly configured. Maybe I did something wrong. Oh, it says here that that's expected. The CNI bridge interface CNI 0 does not get created until the first pod is scheduled on the node. It's created on demand when Kubelet calls the CNI plugins to set up networking for a pod. So we can schedule a test pod. I think I'm going to hold off on that until I'm at least finished with the rest of this, and then we'll see. We'll try like deploying a single pod like BusyBox or something in Nginx and see how it looks like. All right, so we finished deploying kubelet. Next would be kube-proxy. So let's create another script. Call it kproxy. User bin env shell. Then we're going to source the env file. Okay, let's see what we're doing here. So we're going to download the kube-proxy, set the execution bit, copy it over to user local bin. What's the next step? Then we're going to create the kube-proxy directory, and then copy the kube config that we created prior into the kube-proxy configuration folder, or the varlib kube-proxy folder at kubeconfig. And then we're going to create a manifest for the kube-proxy that basically just describes the the configuration. So client configuration is going to use the kubeconfig, the mode of the proxy to use, which is IP tables, and then the cluster CIDR block address space. So here. Then we're going to create the actual proxy service, the systemd service for kube-proxy. It's going to run the binary that we copied over, pass in the new configuration file that gets created, and then set some additional stuff up. All right, so let's add the usual systemd commands, and we're going to add one systemctl status kube-proxy. The last one I didn't do that for the I don't know if it was for Cube. Yeah, I think it's for kubelet. It was system status kubelet. So we have the Kubernetes proxy, or the kube-proxy service that we have to install now. Now let's go and just confirm everything looks good. Yeah, everything looks good so far. All right, let's go run it. Great. Let's modify our status script to include the systemctl status kube-proxy.service. Now, if we were to run it, it should also include the kube-proxy now. Perfect. All right. And we can also check the journal, so that the logs. We never did that for kubelet, so let's look at kubelet as well, and then we'll look at okay. This is interesting. It was saying that it was successful in registering the node, but then it had an error in updating the node status. Then it doesn't exist. Fast updating status as it just became ready. Watching API server. Okay. All right. So I think we're good. Do another get nulls real quick. All right. So that's still showing as ready. We're good there. We check the kubelet and did we check kube-proxy? We have not. All right. Okay. Looks good so far. All right, so next is enabling IP tables for bridge traffic. By default, Linux does not pass bridge traffic through IP tables. This breaks kube-proxy service IP handling when two pods on the same node communicate via service. The fix is to enable BRNet filter module and set the appropriate sysctl parameter, so the kernel tuning parameters. This should already be done via cloud init from the VM creation step, but we can verify. It is. It's there, but I'm not sure if this is the correct value. I think that needs to be set to 1. Oh, okay, so it says the 0 just means no active users are referencing it right now, which is normal. It is still loaded and active. Okay. So there's nothing we need to do here. We can schedule our first pod. All right, let's do that. So kubectl get pods, gonna say, way, it's running, that's good. Oh, we can check the networking now. Yeah, there you go. Remember how we were not seeing the CNI earlier? The network that it's supposed to create? We created it now. So that's nice. And we can exec into the pod. Oh, it's not, I don't think it's, wait, what? It says here, internal error occurred, unable to update connection, forbidden. Oh, this is RBAC. We don't have the necessary RBAC rules for my user to be able to exec into it. So I'd have to, that's interesting, for the user Kubernetes. Interesting. And it says resource nodes. I think there is another follow-up a follow-up section on RBAC. So I'm going to leave it here for now, and in the next one we'll follow up on RBAC. But this is progress at least. Let me see if I can do a git pods. Yeah, it's still running, so that's good. Yeah, so to summarize, we installed the CNI, we installed kubelet and the proxy, kube-proxy. Then we were able to confirm that we could get nodes, do get nodes, and that we could run a pod. It's not the last step in all of this, but it is certainly progress, right? When we started all of this, we just had a VSI. We didn't even have a virtual machine. But now we do, and Kubernetes is installed and configured, albeit that probably not completely configured, but hey, this is a step in the right direction, I'd say. So thanks everyone for following. I hope that see you in the next one. Take care. Bye.